So hello, Mr. Huskens. Hello everyone. Today we're gonna do an interview for knowing more about the life of Mr. Huskens and in his field of studies and of research. So, Mr. Huskens, tell me your story. Where are you from? What is your education?
All right. Yeah. Well, I'm from the Netherlands. I actually grew up in the south of the Netherlands and studied chemical engineering after high school in Eindhoven. Then decided that I liked doing research, so I wanted to get a PhD. And, finding a position at that time was not trivial, so you had to apply in different places, and I got accepted in Delft.
Okay.
So there I did a PhD in what is called coordination chemistry. So it's on the interaction between molecules and metal ions, typically. And after my PhD, I still like doing research a lot, and I wanted to pursue an academic career, so stay in universities. But that meant that before getting a permanent position, you typically have to go abroad for postdoctoral experience, as it's called. So I went to the States for 2 years, and then was in Germany for 1.5 years. And then a position here at Twente was being advertised, for which I applied and got it, which is now more than 25 years ago. So that's since then I have started here as first as assistant professor, and then moved up the ranks and became full professor in 2005.
Nice.
And since then I have my own group focusing on well, primarily I would say chemistry, but the interaction between chemistry and nanotechnology is, I think, a core thing of what we do. And since a few years also interaction with biology, so try to use the technology that we develop for answering biological questions.
Mm-hmm.
For example, understanding how viruses interact with cell surfaces. And that's one of our key focus points at the moment.
Okay. And what was your motivation for doing those kind of research in that field? What motivates you inside?
Let's say that I have had a broad interest in various areas of chemistry and science in general. And what I personally like is to understand things better, at the same time also to develop tools that work, to develop experimental models that allow us to study things better. And I think that is, for example, what nanotechnology in large part is about, is understanding things at the nanoscale, but also developing tools to make it happen so that you can actually understand things better. So I think for nanoscience, it's clear that the field primarily was sparked by development of probe technologies. So AFM, STM were at the forefront of the start of the whole nanotech field. It's tools that allowed us to look at things at the nanoscale that made it possible and basically ignited the whole field. So for me, I'm fascinated by how molecules interact with each other, and we try to develop tools for that, try to develop a better understanding of how molecules do that. And it's particularly relevant, I would say, in biology, where you have big molecular systems with often complex interactions that have an important function in living systems.
Mm.
That makes it fascinating. So for me, nano is where chemistry, biology, and physics and technology all meet, and you can do interesting things in a multidisciplinary setting.
Nice. And can you tell us about application of one of your current field of study?
Yes. So I briefly mentioned that we were fascinated in developing tools for understanding how viruses bind at surfaces.
Yeah.
And that means, for example, that we have developed a surface at which we cover that surface with a so-called gradient of receptors, basically a gradually varying density of receptors. Viruses are very particular in the density of receptors they need in order to stick to a cell to start an infection. And that is what we try to study with such a tool. And basically, the tool is a sensor that tells us what is the minimum density this particular virus needs for that particular receptor that we put on the surface. So what we hope to understand with it is to have a tool by which we can identify viruses and, for example, for flu, also can map out what different mutations from season to season or in the development of a pandemic would do to affinities and infection levels of the different virus types that occur.
Okay, so it will allow in further studies to maybe capture viruses and prevent them to.
That's I would say an extension of it. It can use the exact same principles indeed that we developed. So we learn what kind of receptor densities such viruses would need, and one of my projects currently in the group is about designing 2D nanomaterials that could function as antivirals. So basically mimicking a piece of a cell membrane that would then actually capture the virus and just take it out of the body without allowing it to infect.
Okay. That's really a nice project actually.
Yeah, it is.
Could help a lot of people. I would say, who are the people that you met that have influenced your life in such direction?
That's a very good question. I would say many people along the way. Starts with early on with your parents stimulating that you go your way and you can follow your interests and your passions. I think that is one of the very most important things. I would say definitely my promoter in my PhD project has been very stimulating, in a sense, always asking very open and curiosity questions, and that's something that always was like, he was never, I didn't see him that often. He was a guy who was always busy, and so I met him maybe once a month or something like that. And then he was always capable of asking a question that would get you thinking, and that's triggered like, okay, oh yeah, I didn't look at it that way. And sometimes it was not useful, sometimes it was useful, but that's enough, to trigger your path and get further with your project.
Okay.
Yeah, nice. That's a good example. Yeah.
Okay. And would you have any advices to give to the people watching us, or
first of all, keep an open mind, I would say. There are many things interesting. Is my general impression. More things than you might initially think. Things usually get more interesting once you dive more deeply into it. So that's my second advice, I would say, is don't stay at the surface, but really dive in the topic, because that's when the fun starts.
Okay, thank you. Thanks a lot.
All right, with pleasure.